Hello. This exercise we want to do a rather tricky integral suitable for years 17 and 18 and above. And I say tricky because we have to use a rather obscure substitution. So let the integral I be the integral with respect to x of 1 over 1 plus x times the square root of 1 plus 2x minus x squared. So we start by letting 1 plus x equal 1 over 1 plus z. And then differentiating, we get dx equals minus 1 dz over 1 plus z all squared. And also to find the value of x in terms of z, x is 1 over 1 plus z minus 1, which is minus z over 1 plus z. So the integral I transforms to minus integral sign dz over 1 plus z all squared times 1 over 1 plus z times the square root of 1 minus 2z over 1 plus z minus z squared over 1 plus z all squared. And that in turn translates to minus 1 dz over square root 1 plus z all squared minus 2z 1 plus z minus z squared, which then becomes minus the integral 2z over the square root 1 plus 2z plus z squared minus 2z minus 2z squared minus z squared, which finally comes down to minus the integral with respect to z 1 over square root 1 minus 2z squared. I'm now going to make a further substitution in case you have a little bit of difficulty recognizing that as a standard integral. And so we let z equal sine theta over root 2. So then dz equals cos theta d theta over root 2. And the integral is minus the integral cos theta d theta all over square root of 2, then square root sine 1 minus sine squared theta, which of course is square root of cos squared theta, which is cos theta. And that cancels out with the cos theta on the top. And we're left with minus 1 over root 2 d theta minus theta over square root of 2, which is then minus 1 over square root of 2 sine inverse z square root of 2, which equals 1 over square root of 2. And then we have to substitute for the z. So that's sine inverse square root of 2 of 1 over 1 plus x minus 1, which then further simplifies down to minus 1 over root 2 sine inverse root 2 bracket minus x over 1 plus x, and we put in the arbitrary constant c at the end, because if you used a slightly different substitution at the end, you'd have got that in terms of inverse cos, and the arbitrary constant absorbs the difference. Anyway, thanks very much for listening.